Good morning, students. So, in the last class, we discussed about the vapor pressure of the liquid solution. Okay, so liquid solid is the liquid solid. So that is explained by what? Who? Raoult's law. So Raoult's law. So there must be a volatile cell. So one should be a volatile compounds. If two different volatile compounds are there, they mixed up with each other, then they will form a binary solution. So based on the vapor pressure, he said for a volatile liquids, the vapor pressure of a component is directly proportional to its mole fraction. Okay, that's what I explained in the last class. So based on that, we will start do numerical story. Okay, so students, before going to numericals, I'll explain one thing that is very important. So in liquid solutions, again they form what? Ideal and non-ideal solution. Ideal and non-ideal solutions. How students? I told you the liquid solute is added, the liquid mixtures are mixed up with each other. One should have the minimum volatility and another should have the maximum volatility. Based on the volatility means it can easily vaporizes. Which one gets easily vaporizes, that shows what? Less vapor pressure. Which one has most volatility, that shows more vapor pressure. So in that they form ideal and non-ideal solutions. So what is ideal solution when it is said to be ideal? What is non-ideal when it is said to be means? I will explain it. So first we will discuss ideal solution. So what is ideal solution means, students? So the solution which obeys Raoult's law in all range of concentration or throughout the mixture, it obeys any concentration, all range of concentration, it obeys Raoult's law. So students, here the heat exchange of mixture is equal to 0, and also changing volume of mixture is also 0. Okay, why? Because so I said this is the ideal solution which obeys Raoult's law means they show almost same type of vapor pressure and all. Here students, the amount of heat evolved is equal to amount of heat released. For the mixture means no heat exchange takes place here, neither heat evolved nor heat released, because amount of heat evolved is equal to the amount of heat released here. While the mixing up of two elements or two components is the volatile solution which obeys the Raoult's law, they are called ideal solutions. For the ideal solution, delta H is 0, that is change in enthalpy, because heat is neither evolved nor released during the formation of the ideal solution. And similarly, volume means volume also, the change in volume is also 0 for this ideal solutions. So these ideal solutions, students. So here what happens? For example, why they didn't show change in enthalpy, change in volume means because assume A is one type of solution and B is one type of solution. AB gives binary solution. AB gives binary solution. So in a pure solvent, here all are A are there. This is a pure solvent. Here B is there. Okay. Then it will form AB type interaction molecules. Okay. So students, here AA interaction and BB interaction is equal to AB interaction. So, in a pure solvent, I told you the binary mixture means two solvents mixed up with each other. This is also a volatile liquid, this is also a volatile liquid. They mix up with each other to form the binary solution AB. So here what happens? In A it is a pure solvent, only A atoms are there. In B it is a pure solvent, only B atoms are there. The interaction between AA and BB is equal to what? Interaction of the force of interaction is present in between A and B. If the solution interaction of the pure solvent is equal to the interactions of the binary solution, then it is said to be what? Ideal solution. So because of this equality, they never should change in enthalpy and then never changing pressure. They never should change in volume also, because both the interactions are equal means we both get different values. So this is ideal solution. Okay. So then what is non-ideal means? Of course you can easily say the solution which doesn't obey the Raoult's law is called as non-ideal solution. So in that non-ideal solution, again types are there. I will say just the second one is non-ideal solution. So non-ideal solution means the binary solution, whatever you may write students, that's your way. But the main thing is you have to mention Raoult's law is not obeyed. Okay? The binary solution which doesn't obey Raoult's law called as non-ideal solutions. For this delta mix H is not equal to 0 and delta mix V is not equal to 0. Okay. So next, in this, as I told you, pure solvents are there, they mixed up with each other, then they form what? The interaction, then they form what? Binary solution. In a pure solvent, different interaction is there. After the solution formation, different interaction is there. So in this students, so this shows deviation with, so in a non-ideal solution which doesn't obey Raoult's law means it shows variations with Raoult's law. How the deviation takes place. So two types of deviation is there. One is positive deviation, another one is negative deviation. So as we are talking about what? Vapor pressure. Talking about vapor pressure. Vapor pressure means vapor is there. Vapor means a gaseous state. The pressure exerted by the elements in the gaseous state is called as vapor pressure. Okay, you remember that. So the positive deviation is there, negative deviation is there. How it shows? So listen, if AA interaction is there, BB interaction is there, these two are what? Pure solvents. Assume this is solute interaction, this is solvent interaction. Then I will take this one as pure components. One is solute, another one is solvent, this is pure component. So if solute interaction and solvent interaction is there, another one AB, if this is solute solvent interaction. So this is what? This is not a pure substance, this is binary solution. Binary solution. So here what happens students? If AA-BB interaction is greater than AB interaction. I hope you understood. AA BB interaction is greater than AB interaction, means the force of interaction with the pure substances is high compared to the force of interaction between the solution. So after the formation of the binary solution. For example, students, so sugar solution is sorry, not sugar solution. Okay, ethanol in water you assume. So ethanol is also liquid, water is also liquid. Ethanol has its own interaction, water has its own interaction. If ethanol mixed with water, then what happens? The interaction between ethanol and water individually is greater than what? Ethanol water interaction. I hope you understood. So this is the interaction. Ethanol means C2H6 C2H5OH. This ethanol interaction is there, this one, and water interaction, this one. This is better than what? C2H5OH and water interaction. There is less force of attraction between this C2H5 and this H2O. I will maintain acetone and ethanol. So how this breaks, students? So listen, I'll write here. You take instead of water, you take acetone, or you just take CH3, sorry, C2H5. OH is there. So many molecules are there, C2H5OH, C2H5OH. When acetone is added to it or water is added to it, assume this is the solute, water is the solute. So in water, this is the solute, means I write the structure of water. So you know this one will form hydrogen bond with the oxygen, correct? Okay, this is the water molecule. You know, this is hydrogen bond, this is covalent bond. This is covalent bond, this is hydrogen bond, this is the water molecule. So this is what? Pure solvent. Okay, how the pure solute is there? C2H5OH bonded to C2H5OH, C2H5OH. Similarly, pure solute is also there. But when solute is added to this solvent, what happens? So listen, if C2H5OH is added, okay, I'll write here clearly, C2H5OH. Here also oxygen is there, here also hydrogen is there. Then what happens? This will break the hydrogen bond with water molecule and it forms hydrogen bond with the oxygen present in the ethanol. I hope you understood. It breaks the bond with the hydrogen atom and it forms a bond with the hydrogen bond with this atom. Again, this hydrogen is there, it breaks the bond here. With the oxygen, it breaks the bond and it forms the bond here. Okay, then here solvent solute interaction is there. If the solvent solute interaction is less, then what happens? It shows positive deviation. Why? Because its interaction is less means the bond gets breaks. Okay, when the bonds breaks means it easily escapes. Easily escapes means that results in increase in gaseous concentration. The gaseous concentration increases means vapor pressure increases. Okay, understood? Here the bond breaks means what happens? Once the bond breaks, the atoms becomes free, that is vapors especially. The water vapors becomes free means they easily escapes. When they easily escapes means that shows what? vapor pressure is high. Okay, so if the solvent solid interaction is less with respect to this, then what happens? It shows a positive deviation. Understood? This is what called solvent-solvent and the solute-solute interaction. So this solvent-solute interaction is more compared to solute-solvent, then it shows a positive deviation. If positive deviation means vapor pressure increases. Why vapor pressure increases means because availability of this is less in pressure. Interaction is less means the bond gets easily breaks and it easily escapes. So the we have Raoult's law value positive means then we will get the graph. Positive deviation is there. X1 is equal to 0, X2 is equal to 1. X1 is equal to 1, X2 is equal to 0. This is mole fraction. This one is vapor pressure. This one is vapor pressure. So then what happens, students? The positive deviation takes in this manner. This is P1 and this increases actually. This one is P2 and this one is okay. This one is P1, this one is P2, this is P total, P1 plus P2. Okay. This shows what? Positive deviation. How students listen, if you take this is Raoult's law deviation. Okay, this is the expected graph we want for what the dotted line represents the graph with respect to Raoult's law. But the graph for this positive deviation that shows what? The non-ideal solution in which the solvent concentration is less with respect to the interaction between the pure solvents means it shows positive deviations means it is greater than Raoult's law curve. I hope you understood. So this is what the graph we expected from what Raoult's law. So in the last class only I did it like the students. Here x1 is equal to 0, x1 is equal to 1, x2 is equal to 0, x2 is equal to 0. This is mole fraction, this is pressure ring. We will get the graph in this manner. Correct? So then, this is the graph we got. Correct? That's what I wrote here, like this. This is the expected graph. Sorry. For this is 1, this is 0, this is 0, this is 1, this graph. If you take this one means, this graph increases means, this will get decreases. Why? Because students, because here we are considering x2 is 1, x1 is 0. We know that the vapor pressure, the formula I wrote, the P total is equal to how much? P1 naught minus P2 naught minus P1 naught into x2 means it only varies with the component 2. So here I taken this means this graph follows the trend. Okay, this is the trend. That's what I wrote here. Okay, this is the graph we expected from Raoult's law, but for this non-ideal solution, the graph is in this manner that shows positive deviation over the Raoult's law. Okay, so that is the graph, and these graphs are important for 2 marks. Explain the graph which shows the positive deviation of the Raoult's law. Okay, understood? I'll explain one thing. So, in the liquid solution, ideal and non-ideal solutions are there. Ideal means which obeys Raoult's law, and it has delta mixture value is equal to 0, and delta mixture change in volume and change in enthalpy is equal to 0. So, there the solvent-solvent interaction, solute-solute interaction is equal to solvent-solute interaction. Okay, in non-ideal solution, what happens? So the binary solution in which it doesn't obey the Raoult's law. Here, change in enthalpy is also not equal to 0, and change in volume is also not equal to 0. Here, so it shows it is not obeys the Raoult's law means of course it shows some variations to the Raoult's law, whether it is positive or negative, that depends upon the nature of the solute and the solvent particle. Here I said the positive deviation is there, that is vapor pressure increases. If positive deviation is there, vapor pressure increases. How? Because so pure solvent, one solute is there, AA, solvent is there, BB. So that is the interaction between solute, solvent is pure, and that is more. Next, after the mixing up of solute and solvent, we will get AB, that is solute-solvent interaction. If the interaction between these two pure solvent is greater than AB, then here the interaction less means force less means it easily escapes. Okay, which easily escapes means increases the rate of vapors and the solution. So if the rate of vapors increases, vapor pressure also increases. For example, if one tank is there, here liquid is there. Okay, so here only 2 vapor molecules are there means vapor pressure is less. If 2 more is there means vapor pressure is more. If more than this means vapor pressure increases. As the number of vapor molecules increases, vapor pressure also increases. Here solvent solute interaction is less. Force between the solvent and the solute is less means it easily escapes, increases the vapor concentration on the surface of the solution, that increases the vapor pressure. Okay, so that's why if the vapor pressure increases means, so with respect to Raoult's law, we want to get this graph, the block color dotted graph, that is the expected graph. But we got this positive deviation from the Raoult's law. So the non-ideal gas which shows the positive deviation from the Raoult's law. This is the general representation of the graph which shows the positive deviation, and this is very important for 2 mark students. They directly ask write the graph for the positive deviations of the Raoult's law, or then ask write the deviations for the Raoult's law, or write the graph for a Raoult's law, positive deviation of Raoult's law, negative deviation of the Raoult's law. Okay, this is positive deviation. Now we will discuss with negative deviation. So the next one is negative deviation. Okay, so this negative deviation again consider solute AA, solute interaction, and solvent BB, that is solvent interaction, and binary solution AB, that is solute solvent interaction. Okay, so students, before I told the solute and the solvent, the interaction between the pure components is greater than what? Interaction between the interaction with the binary solutions. So greater than I said, here what happens? AA and BB interaction is less than AB interaction. means, so in the phenol is there, aniline is there also. Okay, phenol and aniline. Here phenol is the solute and solvent. Okay, solute. Aniline is the solvent here. Phenol is the solute, aniline is the solvent. So here what happens? The phenol interaction and the aniline interaction is present in the reaction. So once they mix with each other, the phenol aniline interaction will start. So this interaction is greater compared to this pure component interactions. Why? So listen, I will take phenol example. Right here, phenol means this one. Okay, aniline means, okay, I'll take like this only. Aniline means this one. So in phenol what happens? So I will take this as a C6H5OH. Another C6H5OH is there. So this oxygen bonds form with this hydrogen form a hydrogen bond. Correct? Next another C6H5OH is there. This will also form bond here like this. They form a hydrogen bond. This is what? AA type interaction. If you consider aniline, NH2 is there. Here this is also electronegative. Then I write this C6H5NH2. C6H5NH2. It will also form hydrogen bond. So this will also which type? BB interaction. So they have their own interaction in the solution where they present. Okay. So if we mix up with each other, here I write this phenol C6H5 mix up with each other, that is C6H5NH2. So students, here it forms hydrogen bond as well as lone pair of electron present on this hydrogen can have the ability to form a bond with the phenol atom. Okay, here electrons are there, here hydrogen is there, so they form easily. So the interaction between this hydrogen and the lone pair of electron, because of the presence of lone pair of electron, interaction is very high. Interaction is high. So if the force of interaction is high, so then they form a strong bond between them. If the strong bond is there, it cannot easily escape. If cannot easily escape means the vapor, the density of the vapors on the solution and over the solution decreases, results in what? Decreasing vapor pressure. Results in decreasing vapor pressure. I hope you understood what I said. So this what happens? The solute to solvent interaction is high means the escaping capacity of vapors is less. Okay. So here what happens? This AA-BB interaction is A less than AB interaction. So again we draw the graph. For that means first I will draw graph for the vapor pressure and mole fraction. X1 is equal to 0, x1 is equal to 1, x2 is equal to 1, x2 is equal to 0 means I told you it always depends on the component 2 means, so the graph again decreases. Correct? Graph decreases means it is this form. Okay, so students, with respect to decreases means I will take the next decreases. This is x2, this is y. Okay, so for this is P1, this is P2. So students, I told you negative deviation means positive deviation I wrote like this. The negative deviation is in this manner. This is also negative. This is also negative. This is also negative. So this is the graph shown negative deviation from Raoult's law. Okay, so the non-ideal solution, if the solute-solvent interaction is more with respect to that, then this shows what? So this one is P1, this one is P2. So this shows what? The negative deviation from the Raoult's law. This is the graph we expect from the Raoult's law. This is the negative deviation we expect when the solute-solvent interaction is greater than solute-solute and solvent-solvent interaction, and this is also important for 2 marks. Okay, so this is all about the ideal and non-ideal solution. That is especially what I got, the solution liquid solution, vapor pressure in liquid solution explained by what? Raoult's law. That types is their ideal and non-ideal. Okay, I told you that is important for 2 marks. So next one, students, the difference between ideal and non-ideal solution, that is very important for 2 marks as these steps. So I write here which are all important for 2 marks. You just note down in the notebook what they are going to ask. So still I explain the vapor pressure means you get 2. Okay. First one is difference between ideal and non-ideal solution. Ideal and non-ideal solution. Where you take ideal, here non-ideal. Okay, the first point here is they obey Raoult's law. Here they doesn't obey Raoult's law. Here delta enthalpy change of mixture is 0. Here enthalpy change of mixture is not equal to 0. Here change in volume of mixture is equal to 0. Here change in volume of mixture is not equal to 0. So this one, it doesn't show deviation. So it shows positive and negative deviation with Raoult's law. So what I am writing here is very important for 2 marks students. You should note down this. This is the difference between ideal and non-ideal solution. So the next one is graph which shows the Raoult's law. Okay, so here the first graph. This is mole fraction x. Here x1 is equal to 1, x1 is equal to 0, x2 is equal to 0, x2 is equal to 1. So here what happens? So this is vapor pressure means, students, if the vapor pressure of the solution increases, okay, so with respect to 0, this component 0 to 1 means the mole concentration of molar concentration or a mole fraction of the second component increases means I told you the Raoult's law P is directly proportional to X. So if X increases, P also increases. This shows the variation like this. So this is 1, this is 2. So listen, the decreasing value is what? P2. This is P1. Okay, that is P1. Increases is P2. This one is P1. This is P total. That is P1 plus P2. This is what? Raoult's law graph. Are you making graph of ideal equation? Because ideal equation obeys Raoult's law. Okay. So second one is graph which shows positive deviation of non-ideal solution from Raoult's law. Okay, I'll draw the graph here. So this is the graph. I hope you understood. Okay, so students, here I am taking x1 is equal to 0, x1 is equal to 1, x2 is equal to 1, x2 is equal to 0. Correct? So listen, this is the second component. As the component mole fraction increases, graph increases. As the concentration of mole fraction decreases 1 to 0 means graph also decreases. Okay, then we will get graph decreases. So then we will get the Raoult's law graph in this manner. So now we are showing what? This is X mole fraction, this is vapor pressure. So here we are showing what? Positive deviation of non-ideal solution from Raoult's law. Positive deviation in this manner. They show positive deviation. Okay, so this is 0 to 1 increases means this is P1, this is P2, this is P total. Okay, for this second one, negative deviation of non-ideal solution from Raoult's law. Okay, so again, this is the graph. This is vapor pressure. This is mole fraction. Here we are taking again x1 is equal to 0, x2 is equal to 1. Here x1 is equal to 1, x2 is equal to 0. So the Raoult's law equation again it decreases. Then we will get, this is the graph here going to get for what? Raoult's law. Okay, so now we are writing the graph which shows negative deviation from Raoult's law. So then the graph follows the negative deviation here, here, and so here this increases means this is P1, this is P2, this one is P total, that is P1 plus P2. So these are very important for how much? 2 marks students. 1, 1. So this one remains, this one, this one, this one. This is only what? The vapor pressure of a liquid solution. Okay, so this is our report, the liquid solution. So now we will discuss the solids, vapor pressure of the solids in liquid solution. The vapor pressure of a solids in liquid solution. So listen, before going to explain that, I will explain you about azeotrophs. Okay, this is also an important thing, that is azeotrophs, the binary mixtures which have the same composition of liquids. The binary mixtures which have the binary mixtures which have same composition of liquids is called as azeotrophs. Okay, so students, in this liquid, same concentration of liquid and vapor phase and boils at constant temperature called as what? Azeotrophs. Okay, the binary mixture which has same composition of liquid and vapor phase and boils at constant temperatures. In that two types is there, student. One is minimum boiling point azeotrophs and maximum boiling point azeotrophs. What is this minimum and maximum? So boiling point is minimum means they easily convert into gases. So in the positive and negative deviation, so binary solutions which show positive deviation are called as minimum boiling point the azeotrophs with the minimum boiling point. Why? Because as I told you, positive deviation means the solute-solvent interaction is less, okay, then it easily escapes from the solution. So then the vapor, concentration of the vapor phase increases, so that results in what? If the concentration remains same, students, it require only less temperature to boil the liquids. Okay, the minimum boiling point azeotrophs nothing but the solutions which shows positive deviation. So maximum means the solutions which shows negative deviation. So this is azeotrophs. Azeotroph means this is important for 1 mark. What are azeotrophs? The binary mixture which have same composition of liquid and vapor phase and boils at the constant temperature. Here two types is the minimum boiling point azeotrophs and also maximum boiling point azeotrophs. Here minimum boiling point means one who shows the positive deviation with the Raoult's law. Maximum boiling point azeotrophs means one which shows the negative deviation from the Raoult's law. So this is for today's class. In the next class, we will discuss about the solids, the vapor pressures of solids in liquids and also some numericals based on these topics. Okay, thank you.